Good morning, everyone. Today, let us talk about the Programmable Logic Controller, Unit 5, Session 1. Introduction to Programmable Logic Controller and Memory Devices. Today, let us talk about Programmable Logic Controller and the memory devices. The main objective of this session is to see what is PLC, a programmable logic controller, various memory devices like what is RAM, random access memory, types of RAM, ROM, read-only memory, classification of ROM. What is a programmable logic controller? A PLC is a digital computer and it is used for the automation of various electromechanical processes in industries. PLC is designed to survive in very harsh environments, and the PLC is shielded from heat, cold, dust, and moisture. It consists of a microprocessor and it is programmed using a computer language called ladder logic. Programmable logic controller ಒಂದು ಡಿಜಿಟಲ್ ಕಂಪ್ಯೂಟರ್ ಇದ್ದ ಹಾಗೆ ಅದನ್ನು ನಾವು ಎಲೆಕ್ಟ್ರೋಮೆಕ್ಯಾನಿಕಲ್ ಪ್ರೋಸೆಸಸ್ನ ಆಟೋಮೇಷನ್ ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೇವೆ. PLC ತುಂಬ ಎಫಿಷಿಯೆಂಟ್ ಆಗಿ ಹಾರ್ಶ್ ಎನ್ವಿರಾನ್ಮೆಂಟ್ಸಲ್ಲಿ, ಅಂದರೆ ತುಂಬ ಹೀಟ್ ಇರುವಂತಹ ಪ್ಲೇಸಸ್ಸಲ್ಲಿ, ತುಂಬ ಕೋಲ್ಡ್ ಇರೋ ಪ್ಲೇಸಸ್ಸಲ್ಲಿ, ಡಸ್ಟಿ ಎನ್ವಿರಾನ್ಮೆಂಟಲ್ಲಿ ಮತ್ತು ಹೆಚ್ಚು ಮಾಯಿಶ್ಚರ್ ಇರೋ ಎನ್ವಿರಾನ್ಮೆಂಟಲ್ಲೂ ಕೂಡ ನೀಟಾಗಿ ಕೆಲಸ ಮಾಡ್ತದೆ. PLCನಲ್ಲಿ ಮೇನ್ಲಿ ಮೈಕ್ರೋ ಪ್ರೊಸೆಸರ್ ಇರ್ತದೆ. ಆ ಮೈಕ್ರೋ ಪ್ರೊಸೆಸರ್ನ ನಾವು ಲ್ಯಾಡರ್ ಲಾಜಿಕ್ ಯೂಸ್ ಮಾಡಿ ಪ್ರೋಗ್ರಾಮ್ ಮಾಡಿರ್ತೇವೆ. The block diagram of a programmable logic controller contains the input module, the output module, CPU, user memory, data memory, serial port. So the serial ports are connected to the programming device. A PLC ಅಂದರೆ PLC ನಲ್ಲಿ ಒಂದು ಕಡೆ ಇನ್ಪುಟ್ ಮಾಡ್ಯೂಲ್ ಇರ್ತದೆ, ಇನ್ನೊಂದು ಕಡೆ ಔಟ್ಪುಟ್ ಮಾಡ್ಯೂಲ್ ಇರ್ತದೆ. ಇನ್ಪುಟ್ ಮತ್ತು ಔಟ್ಪುಟ್ ಮಾಡ್ಯೂಲ್ಸು ಸೆಂಟ್ರಲ್ ಪ್ರೊಸೆಸಿಂಗ್ ಯೂನಿಟ್ ಇಂದ ಕನೆಕ್ಟ್ ಆಗಿರ್ತದೆ ಆ್ಯಂಡ್ ಇಟ್ ಹ್ಯಾಸ್ ಗಾಟ್ ದ ಪವರ್ ಸಪ್ಲೈ. ಇನ್ ಎ PLC, usually the program is written on a computer and then it is downloaded to the PLC via the cable. The loaded programs in a PLC are stored in a non-volatile memory. We use a visual programming language called as the ladder logic. PLCಗಳಲ್ಲಿ ನಾವು ಕಂಪ್ಯೂಟರ್ನಲ್ಲಿ ಪ್ರೋಗ್ರಾಮನ್ನು ಬರೀತೇವೆ. ಕಂಪ್ಯೂಟರ್ನಲ್ಲಿ ಪ್ರೋಗ್ರಾಮನ್ನು ಬರೆದ ಮೇಲೆ ಅದನ್ನು PLCಗೆ ಡೌನ್ಲೋಡ್ ಮಾಡ್ತೇವೆ ಕೇಬಲನ್ನು ಯೂಸ್ ಮಾಡಿ. ಪ್ರೋಗ್ರಾಮ್ಸ್ಗಳನ್ನ ನಾನ್ ವಾಲಟೈಲ್ ಮೆಮೊರಿನಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡಿರ್ತೇವೆ PLCನಲ್ಲಿ. ಮತ್ತು ಒಂದು ವಿಜುವಲ್ ಪ್ರೋಗ್ರಾಮಿಂಗ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಅಥವಾ ಒಂದು ಸ್ಕೆಚ್ ಇರುವಂತಹ ಒಂದು ಪ್ರೋಗ್ರಾಮಿಂಗ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಲ್ಯಾಡರ್ ಲಾಜಿಕ್ ಅನ್ನೋ ಒಂದು ಪ್ರೋಗ್ರಾಮಿಂಗ್ ಲ್ಯಾಂಗ್ವೇಜನ್ನು PLCಯನ್ನು ಪ್ರೋಗ್ರಾಮ್ ಮಾಡಲಿಕ್ಕೆ ನಾವು ಯೂಸ್ ಮಾಡ್ತೇವೆ. Introduction to memory. Let us see different types of memories that are used in digital devices. In computing, memory mainly refers to a physical device. These physical devices are mainly used to store the programs or the data temporarily or permanently for use in a computer or in a digital electronic device. So this figure shows the location of the temporary memory in a CPU of a computer. Main memory or primary memory in a computer is divided into two parts: random access memory, which is also called as read-write memory, and read-only memory called as the ROM. This slide shows us the different types of memories used in digital devices. So starting from the magnetic tapes, optical disc, and the magnetic disc, we call it as the external memory. The main memory, RAM and ROM, cache memory, CPU registers, we call it as the internal memory. As we move from bottom to the top, the accessing speed increases in the memory devices. Here we have the block diagram of RAM, random access memory. It has got 8-bit address line, 8-bit data line, read pin, write pin, and a chip select pin. Random access memory or the RAM. The RAM chip is an integrated circuit which is made up of millions of transistors and the capacitors. It is the most common form of computer memory. There are two types of random access memory: dynamic RAM and the static RAM. Dynamic RAM is called as DRAM. It mainly consists of transistors and capacitors. Static RAM is a semiconductor memory. It uses flip-flops to store each bit of data. Basic understanding on the working of RAM. Whenever we run a program or we run any application program or open a file, it is initially loaded temporarily from hard drive into our RAM. Once it is loaded to the RAM, we can access that file very smoothly with minimum delay. Data is stored randomly on the RAM and we can access it directly. If we run out of the RAM, if the RAM space is less, the computer hangs. This is the basic understanding of how the RAM works. Hard drive and the user is connected by a RAM. So whenever we require a file from the hard drive, so the file from the hard drive is initially loaded to the RAM and the user will make the necessary changes in the RAM. After making the necessary changes, it can be again stored in the hard drive. So whenever we call a particular file to the RAM and we do editing, so the access time required is going to be very less. Typical RAM and its location in the motherboard. These are the RAM chips. So these RAM chips are inserted into the slots of the motherboard as shown here. Types of RAM. It is static RAM. Static RAM has got semiconductor memory. It uses flip-flops to store each bit of data. It does not read periodic refreshment or refreshing. It is fast and it consumes very less power. It is very expensive and it has got very complex structure. Coming to the dynamic RAM, it stores each bit of memory in a capacitor in an integrated circuit. Usually capacitor leak charges, so we need to refresh it periodically. It is simple in structure. It has got one capacitor and one transistor bit per bit, so its density is very high. This is the location of DRAM in the motherboard. What is the importance of RAM? The RAM is used to load and run the operating systems. It enables faster access to the data. The accessing time is reduced. Coming to the limitations of RAM, it has got limited amount of data storage, and it is mainly a temporary memory, and it is very expensive. Coming to the read-only memory or the ROM, we cannot add new contents to the read-only memory. The data we can only read, so we cannot write any data into the read-only memory. It is mainly used to store the instructions which are permanent in nature. It is mainly used to supervise the hardware. It is mainly used to store operating system programs and programs which are dedicated for microprocessor applications. Classification of ROM. ROM is classified as MROM or masked ROM, PROM, programmable ROM, EROM, erasable, EPROM, EEPROM, erasable programmable ROM, electrically erasable programmable ROM. The block diagram of a ROM shows address, 8-bit address line, 8-bit data line, chip select pin, and read pin. It has no write pin here. This is the location of ROM, read-only memory, in the motherboard. Let us see a video on the various types of memory devices.
In many ways, our memories make us who we are, helping us remember our past, learn and retain skills, and plan for the future. And for the computers that often act as extensions of ourselves, memory plays much the same role. Whether it's a 2-hour movie, a 2-word text file, or the instructions for opening either, everything in a computer's memory takes the form of basic units called bits, or binary digits. Each of these is stored in a memory cell that can switch between 2 states for 2 possible values, 0 and 1. Files and programs consist of millions of these bits, all processed in the central processing unit, or CPU, that acts as the computer's brain. And as the number of bits needing to be processed grows exponentially, computer designers face a constant struggle between size, cost, and speed. Like us, computers have short-term memory for immediate tasks and long-term memory for more permanent storage. When you run a program, your operating system allocates area within the short-term memory for performing those instructions. For example, when you press a key in a word processor, the CPU will access one of these locations to retrieve bits of data. It could also modify them or create new ones. The time this takes is known as the memory's latency. And because program instructions must be processed quickly and continuously, all locations within the short-term memory can be accessed in any order, hence the name random access memory. The most common type of RAM is dynamic RAM, or DRAM. There, each memory cell consists of a tiny transistor and a capacitor that store electrical charges, a 0 when there's no charge, or a 1 when charged. Such memory is called dynamic because it only holds charges briefly before they leak away, requiring periodic recharging to retain data. But even its low latency of 100 nanoseconds is too long for modern CPUs. So there's also a small, high-speed internal memory cache made from static RAM. That's usually made up of 6 interlocked transistors, which don't need refreshing. SRAM is the fastest memory in a computer system, but also the most expensive, and takes up 3 times more space than DRAM. But RAM and cache can only hold data as long as they're powered. For data to remain once the device is turned off, it must be transferred into a long-term storage device, which comes in 3 major types. In magnetic storage, which is the cheapest, data is stored as a magnetic pattern on a spinning disk coated with magnetic film. But because the disk must rotate to where the data is located in order to be read, the latency for such drives is 100,000 times slower than that of DRAM. On the other hand, optical-based storage like DVD and Blu-ray also uses spinning disks, but with a reflective coating. Bits are encoded as light and dark spots using a dye that can be read by a laser. While optical storage media are cheap and removable, they have even slower latencies than magnetic storage and lower capacity as well. Finally, the newest and fastest types of long-term storage are solid-state drives, like flash sticks. These have no moving parts, instead using floating gate transistors that store bits by trapping or removing electrical charges within their specially designed internal structures. So how reliable are these billions of bits? We tend to think of computer memory as stable and permanent, but it actually degrades fairly quickly. The heat generated from a device and its environment will eventually demagnetize hard drives, degrade the dye in optical media, and cause charge leakage in floating gates. Solid-state drives also have an additional weakness. Repeatedly writing to floating gate transistors corrodes them, eventually rendering them useless. With data on most current storage media having less than a 10-year life expectancy, scientists are working to exploit the physical properties of materials down to the quantum level in the hopes of making memory devices faster, smaller, and more durable. For now, immortality remains out of reach for humans and computers alike.
So on the completion of this course, students, you should be able to know what is a PLC, what is a memory device, what are all the different types of memory devices like RAM, random access memory, different types of RAM, ROM, read-only memory, and the classification of read-only memory. This is the references. These are the references. Coming to the multiple choice questions, any electronic holding place where data can be stored and retrieved later whenever required is A. Memory, B. Drive, C. Disk, D. Circuit. The answer is A. Memory. What is true about memory unit? A. Memory unit is the collection of storage units or devices together. B. The memory unit stores the binary information in the form of bits. C. Both A and B. D. None of the above. The answer is C. Both A and B. When power is switched off, which memory loses its data? A. Non-volatile memory. B. Volatile memory. C. Both A and B. D. None of the above. The answer is B. Volatile memory. When we work on any document on PC, it is stored temporarily on RAM, ROM, CPU, flash memory, CD-ROM. So it is stored temporarily on random access memory. The answer is A. Which of the following is used to hold ROM, RAM, CPU, and expansion cards, computer bus, motherboard, cache memory, all of these, none of these. The answer is B, motherboard. Which one is random access memory? RAM, ROM, PROM, all of these, none of these. The answer is A, RAM. Random access memory is abbreviated as RAM. SRAM stands for Special Random Access Memory, Supreme Random Access Memory, Static Random Access Memory, Stable Random Access Memory, none of these. SRAM stands for, the answer is C, Static Random Access Memory. Built-in memory of a computer is EROM, ROM, RAM, PROM. Built-in memory of a computer is read-only memory. The answer is B. What characteristics of RAM memory makes it not suitable for permanent storage? Too slow, unreliable, it is volatile, too bulky. The answer is C, it is volatile. The average time required to reach storage location in memory and obtain its contents is called seek time, turnaround time, access time, transfer time. The answer is C, that is the access time. Thank you.